Okay, so Alex said go. So we're going to talk about the next generation of Ethernet and a little bit what's going on in the industry. Some of you have seen some of these slides in the presentation before, but there are actually a lot of new ones and quite a few developments. So I put a flag on the presentation next to the Ethernet symbol, and then I was trying to figure out, is this a start flag or a finish flag? It could be both because the standard is almost finished, but the industry is really just starting, so a little bit of both. Here's what we're going to cover briefly, a little update on the standard, what's going on with form factor and cabling. Of course, the big question is, when can I have it, and what's it going to cost? So basically, there's a lot of activity, so say in 2006 to 2008, and there were a lot of changes, and I was giving all these updates several times a year. And then they kind of went after the first draft into comment resolution and refining the standard. So there wasn't nearly as much exciting information and updates to give over the past couple of years, but that doesn't mean that there wasn't a significant amount of work that was being done. So as far as the specification, the last technical change was in November, and they're now crossing the I's and dotting the T's. So yes, even the IEEE has a sense of humor. At the March meeting, it was decided to proceed to the state of stop making changes. So the draft that we have now, 3.2, looks like the final draft. And in fact, the April meeting was canceled because there was no more work left to do. So that's good news for the schedule. We're on schedule for 2010 to have two new standards. There's also been a lot of activity in the industry. In 2009, we saw a lot of announcements for ASICs and media, and Ixia and Spirent had announcements. Last year at NROP in May, Ixia and Spirent both demonstrated 40 and 100 gig test equipment, and then we had some optics vendors doing various demos at ECOC, and then also last month at the OFC. And then the Ethernet Alliance has always been around promoting Ethernet with education and white papers. So this slide is 4 years old. I actually gave it at GPF 1 4 years ago, so I've been updating it constantly, and it's very exciting for me personally to see this project actually almost be finished and for it actually to be standard and shipping interfaces. So we're basically at the last stage, and there's not much more to do except put on the final touches to the standard. But it takes about 5 years to actually get something like this into the IEEE and out of the IEEE and into a product. So usually I show this slide and talk about what's going to be next, but this time there's basically nothing left to do, and the May meeting will probably be canceled as well. Then we just expect the stand to be done in June, and I always point out that all of the meeting information is public and open, so if you're interested in reading all the minutes and presentations, then you can do that at these URLs. Here's a summary of what's going on, and this slide keeps getting more complicated and has more information, but I wanted to keep it on one page to make sure that all the information kind of makes sense together. The thing to point out here is that just because something is available and specified in the standard doesn't mean that it's actually going to be available to consumers in the first revision. So, for example, there was a lot of excitement about a 40 gig backplane Ethernet signaling that blade server vendors were talking about putting into their backplanes on their blade servers, but no one's really started development on that yet. But that doesn't mean that we won't need it in the future. And then in particular, what's going to be a little bit late is the 100 gig long range media. So we expect that to be available in 2011 or 2012. Everything else that you see on here will be available or actually is available almost today and will definitely be available in shipping products towards the end of the year. let's talk a little bit about these in more detail and about the media options. So Nick was talking about SFP Plus and how it's lower power consumption and all of the advantages. So the 40 gig QSFP module kind of builds on those same principles. It's created for high density and short reach applications. So it's a small form factor, about the size of an XFP, but because of the limited power of the laser, it's just for limited distances. This is already used in InfiniBand today, so it's not a new module. In the industry, we like to reuse as much as possible so that we don't have to keep reinventing the wheel and making things more expensive. And then there's also a longer range application that's specification, but not expected to be available in the initial release. So that's coming, say, next year or the year after. 100 gig CXP, this is also a high density, low power, and short reach interface already used in InfiniBand today. It's also about the size of an XFP. And this is actually an integrated cable assembly. So you can see that the cable is a multi-fiber ribbon cable, and then it plugs into the media with one interface. And we call that just an assembly for convenience. This is the new one. This is a 40 gig and 100 gig CSP module, completely designed from scratch. And you can see it's a much bigger module, about twice as wide as a Zenpak. And this is really what's going to enable us to drive a lot of distance for 40 and 100 gig. So you can see that it's a very hefty module. It has a lot of logic inside. So in particular, the 100 gig modules have what's called a gearbox to convert between 10 and 25 gig signaling. And then there's also a lot of electrical connectors on the interface to the module. So that allows us to do a lot of different things with it. And then if you're into heating and cooling, the CFP designers are very excited about this integrated heat sink that sits on the rails. And there's a lot of exciting innovation that went into that design that you can't really tell from just looking at it, but the designers are excited about it. Here's a lot of cool stuff that you can do with it. So there are already a variety of different CFPs on the market, and in particular, this one is called an MPO or NTP connector, and then we'll talk about that on the next slide. But the initial 100 gig long-range optics are going to be SC connectors, so if you saved all that fiber, now's a good time to start pulling it out to reuse it again. Here's the MPO or MTP cable assembly. This is already used in a lot of data center applications. So you have these patch panels and cassettes for breakout into different smaller cabling sizes, but it's basically just a high-density cable. It either has 12 or 24 fibers, and they're used in parallel for 40 and 100 gig short-reach applications. So one thing to consider is if you're doing a lot of cross-connect in data centers or between internet exchanges or something like that, how is this cabling infrastructure going to need to be changed to support these new applications? In the near term, it may make cross-connect a challenge. And then looking forward, there's already talk about second-generation technology. So if you look at 10 gig Ethernet, the standard came out in 2002, and then over the next several years, lots more things were added to it, like CX4 and 10G base T and LRM. So with 40 and 100 gig, we have the same concept. The standard defines a flexible architecture that you can build things on top of as technology changes and we get better with optical signaling and things like that. So there's already a project to do a 1 by 40 gig optical signaling in the IEEE, and that will likely become an addition to the standard in the next year or two. And then what's really holding us up is the lack of higher speed electrical signaling. So right now, if you look at the internals of a switch or a router, a lot of the signaling is done at 3, 6, or even 10 gig. But what we really need is 25 gig electrical signaling so that we can build faster interfaces and faster ports. So there's a lot of work around 25 gig signaling in the OIF. The OIF is a semiconductor standards body that defines interfaces and electrical specifications and things like that. And once the 25 gig signaling specification is done, then we expect a lot of that work to be able to use to build faster signaling and cheaper interfaces for 40 and 100 gig. Okay. So let's see, are there any questions on this section? Yeah. All right. Well, keep moving on. So let's talk about the market pricing and trends. These are completely new slides that I just wrote in the past couple of weeks, and I showed them at the GPF and at EuroIX. But people keep asking me, when's it going to be available? When can I have it? And what's it going to cost? And unfortunately, the answer is we don't really know what it's going to cost yet. But we can talk about historical trends. So the first question that I argue with myself about sort of late at night when I can't sleep is, are we too late already? I mean, clearly, from a bandwidth requirements, we've been talking to network operators, since 2005, and you're telling us, yes, we need higher speed interfaces, we need them desperately. Lag is a lot of trouble to manage as we scale into, tens of links. So there's clearly a need for it, but only if it costs less than the n times 10 gig components or links in the interface. So, from a market perspective, it's always careful timing between demand and what we can do with the available technology. So, in the States we have the NSA, which is the intelligence agency, and they can build anything they want because they have pretty much unlimited budget, and they're their own customer, so they can build supercomputers and all this stuff to do advanced cryptology, but that doesn't mean that they can sell it to people and that there's a market for it. So it's a very careful timing, and if you develop it too soon before the market's ready and there's no demand, then there's no customers. But if you develop it too early before the technology is affordable, then it's too expensive and there are no customers. So one thing is pretty clear, that had we started working on this in, say, 2003 or 2004, it would have been available earlier, but it probably would have been a lot more expensive than it is now. And that's really because the 10 gig market has ramped up significantly over the past couple of years in particular, and we're now able to use a lot of the 10 gig technology and also component technology that's come down in price as volume has increased. So I don't think there's a clear answer to this question, is it late? Certainly people are frustrated that it's taken so long to get it into the IEEE and to get it through the IEEE, but on the other hand, the technology is already going to be extremely expensive in the first implementation. And that's mainly because of a lot of development challenges. So if you look at 40 gig, it's relatively easy or comparatively easy to implement because there's a lot of 10 gig technology already. So the initial 40 gig implementations use 4 by 10 gig lanes and a lot of the existing optical modules that you saw, so the QSFP and CXP, for example. So it's mostly integration work instead of development work. 100 gig, on the other hand, really requires a lot of significant R&D investment. We're talking about millions of dollars to develop new ASICs, new components, the new CFP module that you saw. And we're kind of on the bleeding edge with some of the optical signaling. So we're trying to do things as efficiently as possible and as cheaply as possible. But on the other hand, right now the 100 gig optics are expected to be about 4 times as expensive as a 40 gig optic. So remember I was telling you that there's this gearbox component that's required, and this is because the input from the from the Mac or the ASIC is 10 by 10 gig electrical, And then this component right here in the optical media actually has to convert that into 4 by 25 gig optical signaling. And right now there's actually a shortage of this component because there's not a mass market for them yet. So basically the optics vendors are waiting on the gearbox component, and the switch router vendors are waiting on the optics so that we can get this media into a product. They're currently extremely expensive because the optics vendors are basically making samples, and Nick was talking about how Opnex basically hand makes the colored Zen pack. It's kind of the same situation. The media vendors are also hand making these for the router vendors in volumes of 10. I doubt that there are even 50 or 100 of these in the world existing today. So, we're just that much on the bleeding edge of this technology. So, if you look at how to predict the market, it's basically extremely difficult, and at best it's an educated guess. And I love this picture. It came from the Internet is Made of Cats video. Mike, I hope you recognize that I got this into a presentation, but yeah, this is basically what you come up with when you do these market projections. And it's not a fault of the guys that are doing the projections. It's just really difficult. So what happened with the 10 gig market is that there were very lofty projections, and in part based on the telecom boom of the early 2000s and just a lot of sort of irrational exuberance that was running around in the early 2000s. So a lot of companies were burned by these projections and actually went out of business because they invested in 10 gig and then there was a market for it. So a lot of people are hesitant to invest in 100 gig R&D, and there are actually people that consider 10 gig to be a failure in terms of living up to market projections. I think certainly as a technology it's been very successful, but if you look at some of the projections, it's really been far off as far as what we thought was shipping and then what actually shipped. So this is a chart from the Dell'Oro Group. The Dell'Oro Group is a market analyst firm in the U.S. I'm sure some of you have probably heard of them, but if you look at the slope of these lines, sort of during the early adoption years, the slope is kind of shallow, but over here when we thought there was, or when they thought there was going to be a mass market, you can see how just vastly different the projections are in terms of what shipped and the extreme slope of the line between the differences. And then in 2012 and 2013, we're finally kind of seeing a line that goes up and to the right again on the projections. And that's really, after 10 gig has been around for 10 years. So 10 years later, we're finally seeing an increase in getting to market volumes that we expected. So if you look at the average selling price trends between Ethernet or gigabit Ethernet and 10 gig Ethernet, these are not to scale, but they're kind of relative to each other in terms of the years on the market. You can see that in the first couple years, the price came down fairly dramatically for both technologies. So we expect the same thing to happen. As the market grows and as volume increases, the price will come down dramatically. So as a data point, this is $40,000, and right now we're seeing sort of average prices around $1,000. So this is 2010, and then we expect that price to fall even more. And based on the historical data, we know this, where we expect the same thing to happen with 40 and 100 gig in the first couple of years. And if you look at port shipment trends, this is really the telling chart here. Back in 2010, I don't know if you've heard of a guy named Nan Chen, but he was at Nortel at the time, and he was predicting that 10 gig Ethernet would ship 2 million ports in the first couple years when it was out. So 10 gig Ethernet actually hit 2 million ports this year in 2010. So it's just been a dramatically longer ramp-up curve in volume than everyone had expected. And then if we kind of extrapolate what could happen to 40 and 100 gig, we expect volumes to be in the low thousands for 40 gig, and probably in the tens to hundreds of interfaces for 100 gig. So when you have volumes that are that low, it just really makes the technology expensive. So what can we predict? Kind of said this before, but based on the historical prices for gig and 10 gig, we think that prices will fall significantly in the next couple of years, especially driven by volume and then some of that second generation technology. So the 25 gig signaling and then the serial signaling for 40 gig. Those will increase density and lower prices. And then, I don't want people to get sticker shock when they hear of a 100 gig interface costing as much as, say, a luxury SUV or something. But really consider the whole cost of the link when you're comparing the prices of a 10 gig lag versus 40 or 100 gig. So that's pretty much everything that makes up the link: the line cards, the ports, the optics. Nick was talking about power consumption. So 10 ports of 10 gig versus one port of 100 gig is going to consume significantly more power. But you also have to look at your optical and your transport gear. If you own fiber, what's the cost of leasing or installing a DWM system versus the cost of a single interface? And then, of course, there's the operational issues. So the provisioning, management, troubleshooting. Can your NOC deal with the concepts of link aggregation and how to troubleshoot that technology? So kind of wrapping up, what should you expect this year? Well, the finished standard, so like I said, everyone's excited about that. I think you're going to see a lot more announcements from switching and routing vendors and also optical vendors kind of as the standard finishes in June. I think this fall will kind of be the year of announcements. And then, as you saw, the first generation technology is going to be extensive and also low density compared to current 10 gig prices. So in the IEEE, the choices were chosen so that eventually 100 gig will be cheaper than 10 by 10 gig as the industry matures and as we get volume and second generation technology. So initially it's probably going to be an application for early adopters. I talked to a lot of internet exchanges, service providers, also people in the data storage industry that are trying to move terabytes of data around. Right now, honestly, the best way to move a terabyte of data is to put it on an airplane. And that's kind of disappointing. But the whole sneakernet concept is definitely still around. I was talking to a company that works on human genome research, and they're generating, I think, 60 terabits of data a week. And there's just no way to transport that over a network right now. But for people like that, they're really looking forward to this technology, as well as some of the internet exchanges. Mike Hughes mentioned it in his presentation that this is something they're keeping an eye on for next year. So in the near term, lag may be more cost effective for you. And the thing to consider, and I always like to point this out, is that eventually higher speed interface technology makes 10 gig denser and cheaper. So I remember 10 years ago I was using 24 port 100 megabit switches with 2 gigabit uplinks. So now we have 48 port gigabit switches with 2 10 gig uplinks, and in the future it's feasible to think of a 48 port 10 gig switch with 200 gig uplinks, or a multi-port 40 gig top of rack switch. So all those things will come in the future and continue to scale as we move from gigabit and 10 gigabit architectures to terabit router architectures. So for a reasonable density, we basically need to roll out a new architecture and class of devices. So think of several hundred gigs of capacity per slot for a 4 or an 8 port 100 gig card. So all that stuff will be coming in the next several years. And then again, the cost will decrease as technology becomes feasible and volumes increase. And like I said, the CFP modules really are the biggest cost component right now of the interface. The actual line card and ports are not necessarily that expensive compared to 10 gig, but certainly the optics are. So the last slide is what you should do, and this is what I tell people when we talk about planning for the next several years, is look at your network growth and needs for the next 3 to 5 years. And especially with the IPv6 or the coming of IPv6 to kind of state it politically correct. I think people should be looking at what's going on with IPv6 and how is that going to affect your router CAM capacities, and then also look at your bandwidth growth. So don't look at just one single component of your network, and then ask for roadmaps from your optical equipment and your router vendors, from your server vendors. So at the beginning I was saying that server vendors are thinking about making blade servers with a 40 gig Ethernet interface on the backplane and coming out of the box itself. Talk to your transport vendors, your transit providers, your internet exchanges, and basically anyone else that touches your network, and figure out what is missing. So no one's actually deployed 40 or 100 gig technology, at least on a large scale yet. So will it work with your optical network, your cabling infrastructure? Do the speeds and reaches actually meet your needs? So there's no 40-kilometer interface available yet for 100 gigs. So are those timelines going to meet your needs? And figure out, are there going to be interoperability issues? But most of all, start talking to your vendors, because like any new technology, the quicker we start addressing functionality and interoperability issues, the quicker we get something on the market that's actually usable. So if we look in the future, no one has actually asked for networks to be slower. Traffic, I think, will continue to increase. We're basically at the large exchanges seeing traffic double every 18 months, and there's no prediction on how much it's increasing on PNIs. Definitely interface speeds will continue to scale. And in fact, people are already talking about terabit Ethernet. So based on what happens with the 25 gig signaling, it's possible that 400 gig Ethernet could be a next step. We'd like to go to terabit Ethernet, but there's just no way to build it right now and to make it affordable for people. So the NSA could probably build it, or I forgot the name of the, is it M5 or MI5? That's the British intelligence agency. So they could probably do it, but not something that we can put on the market. And then, clearly I think Ethernet is going to be the technology of choice. I don't see very many people in the industry talking about how, fiber channel is going to take over the internet routing market, or how SONET development is the next greatest thing that's going to come in the future. So I think Ethernet is definitely going to be it, and the IEEE, in fact, is very interested in making sure that Ethernet continues to evolve as the bandwidth requirements change and will continue to scale. So that's the last slide that I want to present. I have a bunch of very interesting reference slides that I've stuck on the back. So if you're interested on the IEEE process or a whole bunch of other reference, you can read this in your spare time. So that's it. Any questions? I'm looking at IRC.
Okay, has anybody got any questions? We are running slightly late, so. Or you can question Greg over ILC. Okay, if there are no questions right now, what I suggest we do is that we
well, thanks everyone.
Thank Greg.
I'm going to go back to the webcast and unmute myself there.
Thanks very much, Greg. That actually worked pretty well.